Howdy folks, I'm Keith Bowen and this is Hard Rock University. Now today's video is on Ryan's ore. Ryan lives in Tucson. He's got a mine nearby here. His ore is running about 1/3 of an ounce to the ton, and we worked out a deal where he provides me ore for me to test my equipment. I give him the gold. Works out good for everybody. But anyhow, so here we are. We're crushing the rock in the RC46, and I've pulled the rollers apart to minimize the wear on them, and I'm just using it basically as a jaw crusher. I'm crushing it down essentially to 3/8 minus. From there, we split a sample off, and then we send it over here to the impact mill where it's being crushed with the coarser grind for the input. It looks like we're doing only about 200 pounds an hour through the impact mill. It is still giving a nice good grind. Now, one thing I did notice about this though was it's pretty easy to overfeed at this grind. So I found the key is I'm using the air classification column, and what will happen is it'll get kind of plugged up with coarser material and it will stop the airflow. And you'll notice that because you'll start getting dust out of the inlet here. Now watch what happens is it suddenly just plugs up, boom, there you go. Dust coming out everywhere. There's no airflow going now because the classification column is plugged, basically. I mean, it's not packed solid, it's just when the airflow is going up and you get too much and it slows the airflow, less can go up and gets jammed up in there, and it just becomes a little bit difficult. It just essentially you get no airflow, therefore you can't add any more ore, and it doesn't want to clear itself out too easily. So you want to avoid that when you're using air classification. Aside from that, everything worked well, although the throughput under this circumstance was about 200 pounds per hour as opposed to the 400 that we had before. Now what we're going to do is take the crushed rock, take some of that, and go over to the table and do some preliminary testing and adjusting and try and get it right. Then we're going to do a 50 kilo test to get an actual good recovery number for the table on this ore. Now this is how much gold we have got so far just doing testing on my table. It's about 150 pounds maybe?
Right there, yep.
Yeah. How good a scale do you have at home? Do you have a really precise one?
I can measure that, yeah. I can
okay.
Measure.
Yeah, let me know how much it is and just give me a call or whatever.
Okay.
Okay, so now I'm going to do a test of my new table on Ryan's ore. I won't be able to show you the table because it's not patent applied for yet. What I've got is 50 kilograms of material plus a sample for panning and a sample to send off for the lab. So this will be the head sample, and the reason it's 50 kilograms is because the assay is going to be reported in milligrams per kilogram or grams per metric ton, parts per million, whatever you want to call it. So it makes sense to start out with a nice even metric number. So 50 kilograms is 1/20th of a metric ton. So if it's 1 gram per metric ton, then we should have 1/20th of a gram. Now this is the head grade pan. I'm gonna call that about a 0.2, 0.25 maybe. But anyhow, this is just the pan of the head grade for the table test. And we'll get an assay later, but for right now, that's what we got. Now here's the crushed rock from Ryan's mine. It's a pretty good grind. As you can see, quite a lot of very fines. The first run over the table, I took about 20 pounds. By the time the 20 pounds was done, I was getting too much gold off the end of the table for my happiness. I'd say we were only getting 50% recovery. It's consistent with some of the previous testing. However, when I reran the tailings, I was getting almost everything. Big difference, the tailings were wet. So now what I'm going to do is I'm going to take this ore, add water. You may notice there's a little soap in there. And turn it into a slurry, and then run the slurry over the table. It's going to be a pain in the ass for this situation. However, in the future, it may be a handy way, because we can go straight from the dust collector from the impact mill, get it wet, and then drop it on the table. So we will see what happens now. Now here's the gold from the tailings of the dry feed material. As you can see, it's still a pretty substantial amount considering what we started with. On the other hand, right next to that wet patch, not there, that should do it. That's the gold in the tailings from the wet feed material. This is at the end of the run too, so it's a little more concentrated than some of the other samples I got, but I would say I'm getting 80-90% recovery in terms of head versus tails. Now where the rest of it's going, I'm not exactly sure, but I got a lot of other samples and stuff to do, and we'll figure that out. And here is the actual gold recovered. I got it kind of piled up in the corner. I think you might be able to see the depth there. There's also some heavies. I'm guessing that a lot of that may be slag or something, but the majority of that is gold. So we'll dry this and weigh it tomorrow, and we'll see how much it weighs. And then we'll wait for the assays to come back, and I'll update everything when I get all these assays back. I've got a dozen or more samples, so it'll be an interesting video when I finally get all the results back from those. Okay, and this is a, what is it, Lux Bell scale. Go ahead and turn it on and show them how it works. Do you have any idea how much this cost?
Not a clue. Christmas present. Not very much, I'll bet.
Kids give it to him as a gift.
Zero it.
All you do is just pick it up and weigh your bucket. Sweet. Off of the Amazon. Not sure how much it costs, but I will find out and put it on the video. Look below here. I had an interesting failure on the impact mill. You can see this crack here. Let's see if we got anything white to put behind it. Yeah. It still doesn't show up very well. Anyhow, this is cracked here, allowing this to pivot out. You can see this big gap back here. See my finger in there. You know. And it is now almost directly out from the center of rotation, whereas originally it was not. This one's even a little more perplexing because it's bent, but it hasn't broken yet. I'm wondering if the centrifugal force is enough to bend it. You can see the deformation zone here. Obviously that's from the weld, weld embrittlement there. But is it vibration? Is it centrifugal force? Combination of both. See, there's another one there. Ryan's of the opinion it may be some kind of vibrational effect as it's hitting, it's twanging it back and forth and causing the embrittlement. I don't know, we're gonna fix this up and reinforce it a bit and see what happens. But yeah, interesting, but it failed. Total wear on that is maybe 400 pounds is all. That's definitely not satisfactory. But the wear in here, we've got some wear plates. Now removable wear plates. Hard facing here seems to be doing just fine. The wear on the housing seems to be fine. It's undetectable on these spots here. The tips of the rotors are getting worn. That's clear. That's where the most of the wear seems to be, which is an easy place to hard face. So, it's looking pretty interesting. It's not ready for prime time yet, but it's definitely getting better. Happy prospecting and keep it safe out there.